Imagine standing on Mars, your boots sinking slightly into the red dust. The horizon stretches endlessly beneath a salmon-colored sky. The air is cold, razor-thin, deadly. You pull off your helmet and take a deep breath. But you don't suffocate. You breathe oxygen. The sky above is blue. Clouds drift lazily. Green valleys spread across the once barren plains. It's still Mars, but transformed. Could humanity ever achieve this miracle? Could we terraform an entire planet and make it our second Earth? Before we dive deeper into the science behind this bold dream, hit that like button and subscribe to Deep Space Explained so you don't miss the next journey into the mysteries of the cosmos. Because tonight, we're venturing into one of the most ambitious ideas in human history, the dream of turning Mars into a world we could one day call home. Of all the worlds in our solar system, Mars is the one that feels almost familiar. A day on Mars lasts just 24.6 hours, almost identical to Earth's. It has polar ice caps, mountains taller than Everest, and valleys that stretch for thousands of miles. Billions of years ago, rivers once carved its surface. Lakes shimmered in the sunlight. Mars had a thick atmosphere and liquid water, until it lost both to space. So if it was once alive, could it be reborn? NASA, SpaceX, and countless scientists believe that one day, Mars could be humanity's backup planet, a refuge if Earth ever falls. But to bring it back to life, we'd have to play with forces as vast as nature itself. Right now, Mars is a frozen desert. Its average temperature is minus 63 degrees Celsius. So cold that even carbon dioxide turns to dry ice. To make it livable, we'd need to heat the planet until ice melts, water flows, and the atmosphere thickens. One radical idea? Unleash powerful greenhouse gases, carbon dioxide, methane, or engineered perfluorocarbons, to trap sunlight and warm the air. Elon Musk once suggested detonating nuclear devices above the poles to vaporize frozen CO2 and jumpstart a greenhouse effect. Controversial? Absolutely. But some scientists think we could use giant orbital mirrors instead, reflecting sunlight onto the poles continuously. Could that work? Maybe. But there's a catch. Even if we warmed Mars, we'd still face a deadly problem: its thin, vanishing atmosphere. Mars's air is less than 1% as thick as Earth's. Even with warmth, that's nowhere near enough to sustain life. A human would black out in seconds. So, how do we build an atmosphere? One proposal is to release all the CO2 trapped in Martian rocks and ice. But according to NASA's research, even if we freed every molecule, Mars would still only reach 10% of Earth's air pressure. That's progress, but not enough. Another concept: constructing orbital mirrors several kilometers wide, concentrating sunlight on key regions to spark local weather cycles. Or deploying massive atmospheric processors, factories powered by fusion that continually emit engineered gases. These machines could work for centuries, thickening the air one breath at a time. It's not fast, it's not easy. But then again, neither was creating life on Earth. Mars looks dry, but beneath its surface lies a hidden treasure. Vast reserves of frozen water and ancient ice sheets buried under dust. If we could melt them, we'd unleash rivers, lakes, even shallow oceans. Scientists envision enormous greenhouse domes, where heat and microbes are used to liquefy subsurface ice. Volcanic vents could be reactivated through targeted nuclear or geothermal releases, bringing steam to the surface. Once water flows, everything changes. Moisture could trap more heat, darken the surface, and kickstart a positive feedback loop. Rain could fall again, perhaps for the first time in billions of years. And with water comes the possibility of life. Even if we had water and warmth, Mars's soil is toxic. It contains perchlorates, chemicals deadly to most Earth plants. So, how do we make the soil fertile? Enter extremophiles, microorganisms that thrive in radiation, salt, and cold. Scientists imagine releasing genetically modified bacteria capable of consuming toxic compounds and producing oxygen as a byproduct. This is called biological terraforming, letting life slowly reshape a world, one cell at a time. Over centuries, algae could paint the surface green. Mosses might take hold in sheltered valleys. And then, perhaps one day, trees. But there's a haunting question. What if Mars already harbors life? Microbial, ancient, and hidden underground. Would we be preserving it or destroying it forever? Terraforming Mars isn't just science. It's a moral dilemma. If we alter Mars, we could erase the only natural example of alien evolution we've ever found. To many scientists, that would be cosmic vandalism. Others argue the opposite, that not terraforming Mars might doom humanity, leaving us stranded on a single fragile world. So, which future do we choose? To preserve Mars as it is, or to reshape it in our image? And even if we choose to proceed, how? We'd need technologies we can only dream of. Fusion power for limitless clean energy, self-replicating robotic systems to build planetary infrastructure, magnetic shields to restore a protective magnetosphere and stop the atmosphere from escaping into space. Terraforming Mars would be the largest engineering project in history, not just building cities, but forging an entire biosphere. So, can we really terraform Mars? Not today, not tomorrow, but the first steps have already begun. Each rover, each rocket, each experiment brings us closer to a new frontier. Maybe the true question isn't if we can transform Mars, but whether Mars will transform us. Terraforming is more than science. It's a reflection of our deepest instinct to explore, to adapt, to survive. From the caves of Earth to the craters of Mars, humanity's story has always been written in the stars. And when the first sunrise rises over a green Martian horizon, that will be the day we become a multiplanetary species. If this vision inspires you, like, comment, and share this video. And join us as we build the future among the stars. This is Deep Space Explained, where the universe is not just out there, it's our next home.